In this example, you're being asked to identify the nucleophile as well as its nucleophilic atom, then to identify the substrate and the leaving group of that substrate, as well as the electrophilic carbon atom of that substrate. So we have these two species here. One is a substrate, one is a nucleophile. Let's start with this one here on the left. What we kind of want to look at is we want to try to identify, is there anything nucleophilic about this? Is there anything electrophilic about this? And it kind of helps to look for the leaving group first. You know, is there a good leaving group? So here we can see we have some fluorine atoms, but we know fluorine is a terrible leaving group. So it's not going to be the fluorine that's a leaving group, and therefore this carbon is not going to be the electrophilic carbon that is going to be part of this SN2 reaction. So we got to kind of think about what else it could be. So this one might not be as obvious, but what we can look at is, well, what about this oxygen right here? It's bonded to a carbon. That carbon could potentially be the electrophilic carbon that gets attacked, but that would mean that this oxygen is the leaving group, which would make this whole thing the leaving group. So let me draw that out. If that was actually to act as the leaving group, there's that oxygen. It's bonded to a sulfur, which is double bonded to two oxygens. This would be a fantastic leaving group because this negative charge can now move all around. It can move up to that oxygen, or it could actually move to this oxygen. And those fluorines are going to be inductively pulling electron density, meaning that the resonance and the induction is going to be stabilizing that negative charge. And if that negative charge is stabilized, it's going to be a great leaving group. So I'm not going to draw all the resonance structures there, but they are there, which means that whole thing is the leaving group. So this species is the substrate. This portion of the substrate is the leaving group, which means that this carbon here, which I'm going to dot in red, that is the electrophilic carbon, the carbon that will get attacked by the nucleophile while the leaving group gets kicked out. All right, so we've established all the parts of the substrate. This species right here must be the nucleophile. Again, the potassium ion there, the cation, doesn't really matter. It's not part of the SN2 reaction. So you got to keep in mind those cations are there, but it's actually this species that is going to act as a nucleophile. So that carbon, I'll draw the lone pair on there, that carbon is what is going to act as a nucleophile. That is what is going to attack the red carbon, the red electrophilic carbon. So the species on the left is the substrate, the species on the right is the nucleophile, and the nucleophilic atom is that carbon atom.